हेलो माय डियर मैकेनिकल स्टूडेंट्स, हाउ आर यू ऑल? व्हाट्स अप? कैसे हैं सब लोग? प्लीज डू लेट मी नो थ्रू द कमेंट सेक्शन. This is Chandrasekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S Exam Prep. Can you guys hear me? Those who are watching me live, please respond so that we can start our session on time. And the topic for today's discussion is the most important, most complicated and most interesting topic of thermodynamics, that is entropy. Yes, the entropy is the topic for discussion for today. Hi Ranbir, Jeevan, welcome to the session. How are you all? कैसे हैं सब लोग? नमस्कार, आदाब, शुभ संध्या, गुड इवनिंग, सत श्री अकाल, अस्सलाम वालेकुम, वणकम. So welcome to the session and please do let me know your understanding about entropy. What do you know about entropy? I am all good, I am all fine. Jeevan, good to see you on time. Vishwa, good evening, welcome. What is your understanding about entropy? Keep on writing in the comment section. The more you share your knowledge, the more comfortable you become with the topic. You will enjoy randomness. Amit had said randomness, degree of randomness. Yes, what is the unit of entropy? So you guys are watching me live through the beautiful series, which is very helpful for those who are appearing for GATE 23 examination. The series is a combination of numericals as well as theoretical sessions. So today we will talk about the theoretical discussion about entropy. We will try to understand the basic concept, the basic formula which are required to find out the entropy of a system. Yes, Sagnik, Amit, welcome. Molecular disorderness. Yes, Sagnik, definitely it is one of the coolest chapter of thermodynamics. So many students are having so much problem in the basic understanding everybody is having. But how to apply the concept of entropy in your examination, that makes a little tricky to understand. So we will be talking about the concept of entropy as per your examination point of view, all right? So those who are watching me live, I hope everyone know me. I am taking this thermodynamics from long for this series. And still, if those who are meeting me for the first time, this is my quick introduction. I am a mechanical engineering graduate from IIT Delhi in 2006, and I have also cleared engineering services examination in 2009. And about my work experience, I have worked in Steel Authority of India Limited for a couple of years, as well as I have also worked in a private consulting firm for more than 2 years. So my total industry experience is more than 4 years, and from last 9+ years, I have left my engineering services, I have left my Steel Authority of India Limited, I have left the private consulting firm job. From last 9+ years, I am completely dedicated into teaching, guiding the students preparing for various competitive examination. All right, and these are my subjects which I am quite comfortable with. I don't call myself expert because I am also keep on learning from the students. That is why I keep on asking you to share your understanding about entropy. I will try to get the different opinion from the students about the entropy. So it will help me also to improve myself. So improvement is actually a continuous process. Okay, so do not forget to like, share and subscribe the channel, because all the free sessions which are bringing for you, you will get the notification of all those classes if you will subscribe our YouTube channel. So please do like, share and subscribe so that it reaches to maximum audience and everyone from the mechanical engineering fraternity get benefited. So shall we start? Are you all ready? Please keep your notebook and pen handy. Do not just relax. Do not just sit in front of TV. Please try to maintain the proper decorum to understand the concept in deep detail with your full enthusiasm, energy, and positivity. That will make you to understand the topic in the best possible manner. I will try my level best to make you understand the topic. At the same time, if you have anything to ask, any doubt in any of the concept, you just raise your concern through the comment section. Okay, so this is the complete schedule for 2023 aspirants mastering gate concept for 2023 aspirants, and we are talking thermodynamics, complete thermodynamics, and the timing is 8 p.m. On alternate days the classes are going on. This is my entire schedule for thermodynamics, and after today's session we will be meeting again after Holi. So I wish you all a very happy Holi well in advance. So enjoy the festival of colors with your loved ones, and do not forget to maintain the track of your preparation. That is very, very important. So after the Holi on 20th, we will be again meeting on Sunday evening at 8 p.m. and we will practice the numerical for the same topic which we are going to discuss just now. All right. Yes, Ranbir, Manas, good evening, Ravi. So please keep on writing me in the comment section. So ready for the session? Are you all ready? Entropy is randomness. That is what I have got from the students, the disorderness or randomness. So the story of entropy begins with the Clausius inequality. Do you know what is Clausius inequality? There is a difference between Clausius statement of second law of thermodynamics and Clausius inequality. The one thing is the one thing which is common in Clausius inequality and the Clausius second statement for second law of thermodynamics is both are applicable to a cycle, to apply to a thermodynamic cycle. What is a thermodynamic cycle? When a system is undergoing a thermodynamic cycle, can you just let me know? Hi Naveen, Navan, welcome. Thank you very much for your love and your positive mindset and your energy. I am definitely getting charged up seeing your positive comments, seeing your beautiful comments. So keep on writing your comments to make me charged up so that I will try to make this topic very, very easy, very, very simple and interesting for you. So the Clausius inequality, anybody is having any idea about the Clausius inequality which is applied to a thermodynamic cycle? And according to Clausius inequality, the cyclic integration of del Q by T for an actual thermodynamic cycle, the cyclic integration of given initial and final states are same. So according to Clausius inequality, the cyclic integration, we calculate the cyclic integration for del Q by T, and if we are getting it to be less than 0, if we are getting the value of cyclic integration of del Q by T less than 0, then what can we conclude from here? If the value is coming out to be less than 0 or negative, then we can say our actual thermodynamic cycle is, our actual cycle will be, yes, tell me. What is the actual cycle? If the cyclic integration of del Q by T is coming out to be less than 0, then the actual cycle will be irreversible. And if you are getting the value, so we need to calculate this parameter, this term, and if we are getting it to be 0, then our actual cycle is reversible. Then the actual cycle will be reversible. And if the cyclic integration of del Q by T is coming out to be positive or greater than 0, in that case our actual cycle will be impossible. That cannot be possible in a cycle. So it means either the system is not undergoing the cycle, or the value of del Q by T for the cycle is calculated incorrectly. So this is called as Clausius inequality, and this Clausius inequality is valid for all type of thermodynamic cycles, whether they will be reversible or irreversible, as well as for the refrigeration cycle also, as well as for the refrigeration or heat pump cycle. So this expression is valid for heat engine. This expression will be true for heat pump as well as for the refrigerator. Clear? Now, how this is the basis for defining the entropy? How we can define the entropy from here? Look, is this clear to everyone? I hope so. Anybody is having any doubt? Cyclic integration. Now, if we take the analysis to the next level, then what we have discussed, that cyclic integration of del Q by T for a reversible cycle is equal to what? What is the cyclic integration of del Q by T for a reversible cycle? What is the value of cyclic integration? Suraj, as per my knowledge, it is not out yet. I don't know, because from last 2 hours I am into traveling only. I am coming from those who are in Delhi NCR, they must be knowing that I am coming from Manesar. I have crossed the whole Haryana to take this session. Then I have crossed Delhi also, and then I am in UP now, Noida, to take this session. So from last 2 hours I was traveling. So before that the results were not out. There is a high possibility either tonight or tomorrow the results will be out for GATE 2022 examination. Yes, cyclic integration of del Q by T for a reversible cycle will be equal to 0, isn't it? And as we know that the cyclic integration of a property, do you know the cyclic integration of a property? What is the cyclic integration of a property? When we calculate the change in property for a thermodynamic cycle, what does that give? Cyclic integration or the change in property for a thermodynamic cycle, that is also equal to 0, isn't it? Why? Because for a thermodynamic cycle, as Jeevan said, initial and final states are same, and property is the state function. That is why the change in property for a thermodynamic cycle is always equal to 0. So can we, if we relate these two, can we comfortably say that this term definitely represents a property? Represents a property, isn't it? This term, which term? Del Q by T reversible definitely represents a property. Yes, Sandeep, very nice. Yes, Ray, well done, good. This term definitely represents a property, and the property which is represented by this expression is nothing but entropy. That is known as entropy. Is this clear? So entropy is only represented by del Q by T reversible. That is called as entropy, denoted by S. So because it is talking about del Q in the numerator and T is in the denominator, and that is why the unit is the unit of heat transfer is joule, and the unit of temperature is Kelvin, and that is why the unit is joule per Kelvin. Is this clear? Is it all fine up to this? So del Q by T reversible represent the property del Q by T. Look, it is very important for you to know del Q by T irreversible is not same as del Q by T reversible. Del Q by T reversible is not same as del Q by T irreversible, and this term only represents the entropy. That only represents entropy. Del Q by T irreversible does not represent the entropy of the system, right? Okay, so let us move a little further to understand what exactly is the entropy. But before that, I want you to respond through the comment section to answer this question. I want your answer to this question first, and then we will proceed further. There are 4 equations or 4 options containing some expressions. Which expression will be correct for describing an irreversible heat engine? Heat engine is a work producing cyclic device. Heat pump is a work consuming cyclic device, and refrigerator is also a work consuming cyclic device, right? So for the heat pump, which of the following options is correct? Can I have your opinion? Or is it MSQ? Or is it MSQ, multiple options? Are the multiple options correct? Or is it only a single option? Yes. So first of all, from the Clausius inequality, because it is irreversible, so cyclic integration of del Q by T for irreversible cycle is less than 0. So that cannot be true. This cycle is impossible. That cannot be true. That is impossible because of this, because that is violating the Clausius inequality. And what about option A and C? Because it is a heat engine. Heat engine is work producing cycle. Work producing cycle, and work produced is taken as positive and work consumed is taken as negative. That is the sign convention for work. So it is work producing cycle. So W or cyclic integration of del W must be positive, isn't it? It must be positive for heat engine. For heat engine. And from the first law of thermodynamics, for a cycle, cyclic integration of del Q is equal to cyclic integration of del W. Why? Because the change in energy will be equal to 0. Energy is a point function. Energy is a property. That is why the change in energy will be equal to 0. I hope it is clear. And that is why, because this is positive, so this term will also be positive. So it is the cyclic integration of del Q is positive. Option A is correct. Option A will be correct. Option A will be the right answer for this. Option C will be correct for refrigerator or heat pump. Option C will be correct for a refrigerator and a heat pump, because for a refrigerator and heat pump, they are work consuming cyclic device. That is why work should be negative, and cyclic integration of del Q will also be negative. I hope it is clear. Now let us talk about the entropy. Let us talk about the entropy. What exactly is the entropy? The unit is joule per Kelvin. The unit of entropy is joule per Kelvin. It is the extensive property, extrinsic property. What is extensive property? What is extensive property? When do we call the property can be divided into 2 parts? One is intensive and another is extensive. Extensive property means it depends on mass. Depends on mass. Mass dependent property, which is the measure of molecular disorderness and molecular randomness existing in the system. More is the disorderness in the system, means there is less certainty, or there will be more uncertainty in the system. It means the entropy of the system will be more. More entropy means more uncertainty or more disorderness, more randomness in the system. And when the disorderness in the system is more, can we say the system will be less efficient? Can we say the system will be less efficient? Right? How we can say more is the entropy? So to make the system more efficient, we need to reduce the entropy of the system. Lesser is the entropy, more will be the efficiency of the system. More will be the entropy, lesser will be the efficiency of the system. So the efficiency and entropy are inversely related with each other. For an example, let me give you an example. If we are going to a library, and in the library, the books are arranged in random manner. The books are kept in a random manner. Some book is kept somewhere, another book is kept somewhere else. There is no organization, or it is the books are kept in a disorganized manner. So it will become difficult for you to find your required book, isn't it? It will take longer duration to find out the required book. But in another library, if the books are arranged in a organized manner, either alphabetically or some other organized manner, so it will, when you try to find out the book from that particular library, it will be easier for you to identify your required book. So the system will be more efficient if the disorderness is less. The system becomes less efficient if the disorderness is more. So if you are studying for examination, and if you are following a particular study plan, then your efficiency will be definitely greater rather than following the preparation strategy randomly. Whatever you feel like, you just study the topic or the book. Whenever you feel to study thermodynamics, you study one chapter from the thermodynamics, and then after that you study one chapter from the strength of materials. If there is no proper order, then definitely your efficiency of getting the good marks in your examination will be lesser. So entropy, more is the entropy, lesser will be the efficiency. And generally this is the order of entropy for a system consisting of a gas. The entropy of gas is very large because of the molecular motion, random motion of the molecules compared to the liquids, and liquids are having more entropy compared to the solids. Solids are having the least amount of entropy. There is no randomness in solids, so we can say solids are having zero entropy. And another point is, unlike energy, entropy, that is again the property which is non-conserved property. Why do we call it as non-conserved property? We will discuss it later on. And because entropy is a property, it is exact differential. It does not depend on the path of the process followed by the system. Yes, the objective is to reduce the entropy of the system, or you should reduce the entropy of your preparation, then your preparation will be more efficient. Yes, Ray, definitely. Now, can you just let me know if the system is undergoing a process 1 to 2, and if the process is reversible, 1 to 2 is reversible process. If the system is undergoing a reversible process 1 to 2, then the change in entropy of the system is equal to 10 kilojoule per Kelvin. Is equal to 10 kilojoule per Kelvin. During the process, the entropy of the system increases by 10 unit, right? But if the same system is undergoing irreversible process from 1 to 2, if the same system is undergoing irreversible process from 1 to 2, can you just let me know the entropy change for the system? Will it be less than 10 or will it be more than 10? Understood my question? There is a system, thermodynamic system, we define the system. Then the system is undergoing a process where the state of the system changes from 1 to 2. There is a process followed by the system 1 to 2. And if the system, the process 1 to 2 is reversible, then the entropy change for the system is 10 kilojoule per Kelvin. But if I say the process 1 to 2 is irreversible, then what will be the change in entropy for the same system? Will it be greater than 10 or will it be less than 10? Will it be greater than 10 or will it be less than 10? Everyone, please do respond. Waiting for your response. Now, if we talk about energy, if we talk about energy balance, what we can say? Change in energy of the system, change in energy of the system is equal to energy transfer. That is what we have studied from first law of thermodynamics, and the energy transfer is taking place along with the heat transfer, along with the work transfer, and along with the mass transfer. The energy transfer is taking place along with the heat transfer, it is taking place along with the mass transfer, it is taking place along with the work transfer. But if we talk about entropy, let me tell you, the entropy change for the system will remain same whether the process undergone by the system is reversible or irreversible, as long as we are talking about the same initial and final points. Entropy is a property, and the change in property only depends on initial and final states. That does not depend on process path. Didn't I tell you in the previous slide? Entropy is exact differential. It does not depend on the process path, and that is why the change in entropy of the system will remain same whether the process path is followed by the system is reversible or irreversible. Getting it or not? Is this clear? So it will remain same as 10 kilojoule per Kelvin. It only depends on initial and final state whether the process followed is reversible or irreversible. But how to calculate that entropy change? One option is to replace that irreversible path with a reversible path and then calculate del Q by T reversible. How to calculate the change in entropy for the system? What we can say, that is integration 1 to 2, the irreversible path will be replaced by the reversible path. That will give, this is equal to 10 kilojoule per Kelvin. Del Q by T reversible is 10 kilojoule per Kelvin, but del Q by T irreversible is not same. We can say del Q by T for the irreversible path between the same points is less than del Q by T reversible, and that is equal to change in entropy of the system, that is equal to 10 kilojoule per Kelvin. If I ask you del Q by T for the irreversible path, your answer will be less than 10 kilojoule per Kelvin. If I ask you del Q by T value, your answer will be less than 10 kilojoule per Kelvin. But if I ask you change in entropy, your answer will be, it remains same. Is this clear to everyone? Is it clear to everyone? So you need to understand the question, the language of the question, whether the question is asking you to find out the change in entropy of the system. As long as the initial and final states are same, the change in entropy will remain same. But the value of del Q by T will be different for reversible path, will be different for irreversible path. Is this clear? Now, I was talking about, this is the energy balance equation. Now, if we talk about entropy balance, so entropy, or the heat transfer is carrying the energy, work transfer is also carrying the energy, as well as the mass transfer is also carrying the energy. But if we talk about entropy, heat, because heat is disorganized form, of energy. So because it is disorganized form, that carries entropy. that carries entropy. Heat always carry entropy. Heat added to the system will increase the entropy of the system. Heat added to the system will increase the entropy of the system. Heat rejected from the system will decrease the entropy of the system. So heat always carry entropy. But if we talk about work, work is organized form of energy, isn't it? Because work is organized, it does not carry entropy. Work does not carry entropy because work is organized form of energy. Work added to the system or work done on the system will not change the entropy of the system, or work done by the system will also, there will be no change in entropy of the system. So energy transfer is taking place with the heat transfer, work transfer and mass transfer, but entropy transfer is not taking place with the work transfer. Entropy transfer will not take place with the work transfer. Is this clear to everyone? Is it clear? There is one more parameter defined, that is small s, entropy per unit mass. That is called as specific entropy. Before that, because entropy is extensive property, so we can say entropy can be added. Total entropy of the system is equal to S1 plus S2. If there is a system divided into two subsystems, 1 and 2. So the total entropy of the system is S1 plus S2 because it is extensive property. Extensive properties are added or subtracted, or we can say total change in entropy for the system is equal to delta S1 plus delta S2. That is how we can find out the change in entropy for the system. If there is a system consisting of two subsystems, 1 and 2, so the total change in entropy of the system will be change in entropy for the subsystem 1 plus the change in entropy for the subsystem 2. That is how the entropy is an extensive property, extrinsic property, which depend on mass, that can be added or subtracted. Similar to volume. Volume is extensive property. Total volume is V1 plus V2. Similarly, energy is extensive property. Total energy is E1 plus E2. Similarly, entropy is also extensive property. That is why the total change in entropy or total entropy will be sum of entropy of both the subsystems. There is another parameter defined, that is called as specific entropy, which is entropy per unit mass. That is specific entropy. What is the unit of specific entropy? All the specific properties are intensive. You must be knowing. Volume is extensive property, but specific volume, that is defined per unit mass, is intensive property. So specific entropy is joule per kg Kelvin. Right? So specific entropy is intensive, whereas entropy is extensive property. Now, how to talk about entropy balance? The change in entropy of a system. Change in entropy of a system is written like this. Change in entropy for a system is equal to entropy transfer plus there is another term which is called as entropy generation. For a system, entropy generation during the process. So if the system is undergoing a process, if a system is undergoing a process 1 to 2, this is our system, then the total change in entropy of the system, that is S2 minus S1 of the system, will be equal to entropy transfer, and entropy transfer is taking place along with the heat transfer as well as along with the mass transfer. The entropy transfer is taking place along with heat transfer as well as along with the mass transfer, and there is a entropy generation that is happening due to irreversible process undergone by the system. That is our entropy balance equation for any system undergoing a process 1 to 2. Undergoing a process 1 to 2. In case of energy change in energy of the system, we only talk about the change in energy of the system is energy transfer to or from the system. There was no energy generation. That is why energy is a conserved property. Energy can neither be created nor be destroyed. If we talk about energy change, then we only say E in minus E out. So there is no energy generation. That is why energy is a conserved property, whereas entropy is a non-conserved property because of entropy getting generated in the system because of irreversibility associated with the process. So there are important points. So according to second law, in general, any thermodynamic process is accompanied by entropy generation. Any thermodynamic process undergone by the system always accompanied by the entropy generation along with the entropy transfer, and that will make the total change in entropy of the system. And entropy change of a system between two specified states, initial and final, is the same. Do you remember I had given one example, 10 kilojoule per Kelvin? The entropy change of a system between two specified points 1 and 2 will remain same no matter what process or what path, reversible or irreversible, followed by the system during the process. I hope these 2 points are clear to everyone. If anybody is having any doubt in any of the statement written here in the bottom of the slide, do let me know. Please do let me know if anybody is having anything to ask here. All clear? What exactly is entropy generation or entropy production? Energy cannot be generated, but entropy definitely gets generated as generation, which is always greater than 0. Entropy generation or entropy production. Entropy generation is not a property because it depends on the process path, not the endpoints. Process path, reversible or irreversible. Entropy generation always depends on the path followed by the system. Hi Debabrat, welcome to the session. And that is why it is inexact differential. That is why entropy generation is inexact differential. And what exactly is entropy generation? It is the increase in entropy of the system due to internal irreversibilities. Due to internal irreversibility or due to irreversible process undergone by the system. Due to irreversible process undergone by the system. Now more is the irreversible process undergone by the system, more will be the entropy generation. More irreversible process will generate more entropy. So irreversibility is not associated with the change in entropy of the system. There are two different things. Try to understand this. The entropy change of the system depends on endpoints. Because entropy change, entropy is a property. But entropy generation is not a property that is associated with the process path. If the process path is having more irreversibility, the entropy generation will be more, not the entropy change. Entropy change for the system will only depend on the initial and final points. Getting the point clear? Is the point clear? So more is the irreversible process. So by finding the entropy generation, we can actually calculate the irreversibilities associated with a particular process undergone by the system. So the quantity of entropy generation is directly related to the irreversibilities associated with the system. And if the process undergone by the system is reversible, then definitely entropy generation during that process will be 0. Entropy generation will be 0. Getting the point clear or not? That is why entropy generation can never be negative. It is not possible. So each and every thermodynamic process is associated with entropy generation. The value of entropy generation will be 0 if the system is undergoing a reversible process, whereas the entropy generation will be positive when the process undergone by the system is irreversible. Is this point clear? Is this clear? Entropy generation or entropy production, that is associated with the process path. Yes, Jeevan. Now, let us move little further. Now, if we talk about a closed system, what is a closed system? What is a closed system? We can say the system undergoing a non-flow process. Non-flow. Closed system is non-flow. There is no mass transfer. Only heat and work transfer will be taking place. For a closed system, we can say that is why it is called as control mass. Mass is constant. For a closed system undergoing a process from 1 to 2, for a closed system undergoing a process from 1 to 2, there is no mass transfer. So the entropy transfer will only be taking place along with the heat transfer. There is a work transfer also in a closed system, but the entropy transfer does not take place along with the work transfer, isn't it? So if I ask you what is the change in entropy for the system, that is final state minus initial state, can we write integration of del Q by T? That is the entropy transfer taking place with the heat transfer between 1 to 2. And plus there is an entropy generation. This is the expression to calculate the change in entropy of the system. The change in entropy of the system is entropy transfer, which is taking place with the heat transfer only, because work transfer does not carry the entropy, and for a closed system there is no mass transfer. So that is why the term mass transfer will not appear here, and there is an entropy generation due to irreversibility associated. Now if we say the process undergone by the closed system is reversible, then entropy generation will be 0. And if the entropy generation will be 0, delta S for the system, that is S2 minus S1 for the system, is equal to integration of del Q by T. That will give you the value of change in entropy of the system, because the process is reversible and entropy generation will be 0. That is what I have mentioned. For a closed system, the change in entropy can be calculated by using this integration. Integration of del Q by T for a reversible process will give you the change in entropy of the system. Now, during the process, if there is a heat addition to the system, heat is added to the system will be positive. During the process, if the heat is getting added to the system, added to the closed system undergoing a reversible process, so Q will be 0. Do you agree? If Q is greater than 0, if Q is positive, then do you agree delta S for the system will also be positive? When the system is undergoing, when a closed system is undergoing a reversible process in which heat is added to the system, that will increase the entropy of the system. Do you agree or not? That will increase the entropy of the system. Heat addition process will definitely increase the entropy of the system. But during the process 1 to 2, if heat is getting rejected from the system, heat rejected from the system is negative, Q is negative, and if Q is negative, we can say delta S for the system, which is equal to integration of del Q by T between 1 and 2, that will also be negative. That will also be negative, and that implies entropy of the system will decrease. So entropy of the system can increase, entropy of the system can also decrease. Are you getting it? Entropy can increase as well as entropy of the system can decrease. For the heat rejection, reversible process, reversible heat rejection process undergone by the closed system will decrease the entropy of the system. And if there is no heat transfer during the process undergone by the closed system, if there is no heat transfer or adiabatic process, or we can call the system to be thermally insulated system. In case of thermally insulated system, Q will be equal to 0, and if Q is equal to 0, delta S of the system will be equal to 0, or we can say entropy of the system will remain constant. When there is no heat transfer to or from the system, then entropy of the system will not change, and such process is called as isentropic process. That process is known as isentropic process. The process is called as isentropic, constant entropy process. So what we can say here, the conclusion here is a reversible adiabatic process. A reversible is important because we are using this formula delta S for the system is equal to integration of del Q by T. That is what we are using because it is reversible process. That is why entropy generation is 0. A reversible adiabatic process is always isentropic. A reversible adiabatic process is always isentropic. So what did we see from here? We had seen from here change in entropy of the system can be negative, can be 0, can be greater than 0. Do you get it? The entropy change for a system can be positive, can be negative, and it can even be 0. Yes, G1. Well done. Yes, Sandeep. Correct. Is this clear to everyone? So many students are having a notion that the entropy change for the system cannot be negative. So many students are having this notion in mind that entropy change for a system cannot be negative. Definitely it can be negative. It can be positive, it can be negative, or it can even be 0 also. So there is no constraint for getting the change in entropy for the system in any thermodynamic process. That is S2 minus S1 of the system. I hope it is clear. But if the system is undergoing an irreversible process, if the system is undergoing an irreversible process, again the closed system is undergoing irreversible process, then change in entropy for the system is integration of del Q by T 1 to 2, that is irreversible process, plus entropy generation. This will be the expression to calculate the change in entropy for the system when the system is undergoing irreversible process. When the system is undergoing irreversible process, there is an entropy generation which will also be there. The closed system undergoing irreversible process. Now if heat is added to the system, so can we say this term will always be positive? This will be always be positive. That can be negative, equal to 0 or greater than 0. The first term can be positive, can be negative, or can even be 0. Now if there is a heat addition during the irreversible process, if there is a heat addition to the system, Q will be 0. So the first term will be Q will be greater than 0. So first term will be positive and the second term is already positive. So we can say change in entropy of the system will be positive, or we can say entropy of the system increases. Both are positive. Both the terms on the right hand side are positive. So when the system is undergoing yes, Shivam, where you are talking about, which sign you are talking about? Heat addition, heat added to the system will be positive, greater than 0, and entropy generation will be positive. It is also greater than 0 because it is irreversible process. For an irreversible process, there is always an entropy generation. So there is an increase in entropy of the system when the system is undergoing an irreversible process where the heat is added to the system. Now irreversible heat rejection process, then delta S of the system, the first term will be negative and the second term will be positive, S generation will be positive, but Q will be negative. So del Q by T will be negative. So this negative and positive, what will be the final value? What will be the change in entropy for the system? When the system is undergoing an irreversible process, when the closed system is undergoing irreversible process, when the system is undergoing, from here we can write, because this is a positive value, so del Q by T irreversible is, so that is how we can write delta S, change in entropy of the system will be greater than integration of del Q by T irreversible. That is how we can write. That is how we can write. Delta S for the system is equal to, delta S for a system is equal to integration of del Q by T reversible only. And if it is irreversible process, and if we calculate del Q by T, the change in entropy will be greater than del Q by T irreversible. From here we can write, this is the equation, and from here we can write the inequality. S generation is positive, this is a positive quantity. So we can say left hand side will be more than the first term, isn't it? Shivam, that is for your doubt. Is this clear? Actual expression is this. There is an entropy generation coming into picture. I hope it is clear. Please acknowledge so that we can proceed further. Now, my question to you all is, when the system is undergoing, when a closed system is undergoing irreversible heat rejection process, what will be the change in entropy of the system? Will it be positive, negative, or zero? Will it be positive, negative, or zero? So for this, can we say change in entropy for the system can be negative, can be positive, or it can even be zero? Can we say if the system is undergoing irreversible heat rejection process, then the entropy change for the system can be positive, entropy change for the system can be negative, depending on which value is larger. If the first term is large, then the second term, then the overall effect will give you the negative value of entropy change. But if the second term is more than the first term, if the irreversibilities associated are more, then the second term will be more, positive value will be more, then the change in entropy for the system will be positive. But there is a possibility that this, if there is a possibility that if integration of del Q by T is same as entropy generation, in that case, do you agree change in entropy for the system is equal to zero? And this is called as, that is why the process is called as isentropic. The process 1 to 2 can be considered as isentropic, isn't it? What is isentropic process? When there the entropy change will be zero. So there is a possibility of having the system an isentropic process. So this statement, I hope you will be able to understand this statement. An isentropic process may not always be reversible adiabatic. The reverse is not true. That is very important interview question. So many places, so many interviews, students are asked, justify the statement that a reversible adiabatic process is always isentropic, but an isentropic process may not be always be reversible adiabatic. So that is how we can get the isentropic process, but it is not reversible adiabatic. So isentropic process can be achieved in two ways. One is reversible adiabatic, or it can be irreversible heat rejection. It can be irreversible heat rejection. So that is why isentropic process may not always be reversible adiabatic, but a reversible adiabatic is always isentropic. Is this clear to everyone? So entropy change for the system can be positive, can be negative, or even it can be zero. And if the process is irreversible but there is no heat transfer, Q is equal to 0, but entropy generation is positive. So change in entropy for the system will also be positive. So entropy of the system increases. That is for irreversible processes. These are for irreversible processes. For an isolated system, what is an isolated system? Entropy change for an isolated system, that is universe, is an example of isolated system. What is isolated system? When there is no heat transfer, no work transfer, no mass transfer. That is isolated system. So if there is no heat transfer and change in entropy of the system, we already know, that is entropy transfer plus entropy generation. That is the expression. Entropy, change in entropy for the system is this, and entropy transfer is taking place along with the heat and mass transfer, and this is S generation, that is associated with irreversibility. Now can we say, because there is neither heat transfer nor mass transfer, so this term will become 0. So change in entropy for an isolated system, that is universe, is equal to S generation, and the value of S generation is always greater than or equal to 0. If the system is undergoing reversible process, then the universe will have 0 entropy change. If the system is undergoing irreversible process, then the entropy change will be, for the universe, will be positive. What is entropy change for the universe? Can we call it as, what is universe? There is a system, there is a surrounding, and system plus surrounding together makes the universe. So we can say change in entropy for the system plus change in entropy for the surrounding should always be, that is equal to entropy generation should always be greater than 0. That is how entropy change for an isolated system can never be negative. Entropy change for universe cannot be negative. That is not possible. Not possible. And that gives us the entropy. Yes, that gives us the concept of, so we can say those processes are impossible for which entropy change for the universe becomes negative. Those processes are impossible for which entropy generation, that is entropy generation, becomes negative. So those processes are impossible. That is why the second law is called as directional law. That is why the second law is called as directional law. It gives the direction to a particular process through the concept of entropy. And according to second law of thermodynamics, it says only those processes are possible in nature which either increases the entropy of the universe, or even if the entropy of the universe remains constant. The processes which decreases the entropy of the universe are impossible. The processes are impossible which decreases the entropy of the universe. So entropy of universe never decreases. That is the concept of entropy of universe can never decrease. Entropy of the system can increase, can decrease, can remain constant, but entropy of universe can either increase or remains constant. When it remains constant, when the process undergone by the system is reversible. And the more is the irreversible a process, the more will be the entropy generation and more will be the entropy increase of the universe. So entropy generation can be used as a quantitative measure of irreversibilities associated with a particular process. I hope it is clear to everyone. I hope it is clear to everyone. That is what is all about entropy change. Entropy change for a finite body. Finite body means having a temperature change. If it is having a temperature change, initial to final, then how to calculate the entropy change for a finite body? If it is a finite body, then there is no mass transfer. There is no mass transfer. So entropy change of the finite body or a liquid with a temperature change is equal to integration of del Q by T. And what is del Q? That is mc dt. So change in entropy is equal to integration of m into c into dt by t and initial to final. That is the change in entropy for the system, finite body. Mass into specific heat into natural log of final temperature by initial temperature. It can be positive, it can be equal to 0, it can be negative. That is how we can calculate the change in entropy for a system which is undergoing a temperature change. When it is having a temperature change, it can be a liquid with a temperature change. That is how we can find out the entropy change. And entropy change for a thermal energy reservoir. What is thermal energy reservoir? Temperature is constant. Or if it is a fluid with a phase change, temperature remains constant. In that case, if it is a source, do you know what is a source? If it is a source at temperature T1, the heat is rejected from the source. Temperature T1 is constant. So because heat is rejected, that is negative. So for the source, if you want to find out the change in entropy for the source, we can say it is minus Q by T1. If it is a sink having temperature T0, the heat is added to the sink. So Q is positive. So change in entropy for the sink is equal to plus Q by T0. There is an increase in entropy. Sink will have an increase in entropy. Source will have a decrease in entropy, isn't it? And if the fluid is undergoing a phase change, in that case, delta S for the fluid is equal to we can write m into latent heat by temperature T. Temperature of the fluid, TF is constant. The temperature of the fluid is constant if it is undergoing a phase change. LH is latent heat. That is how we can find out the change in entropy for a reservoir, or if the system is having a constant temperature, then this is how we can find out this is how we can have the. So I think that is all for today. We will continue our discussion. We will meet again. Yes, that is all from my side. We will continue our discussion, or we will discuss more on 20th of March. We will have some numerical practice, and then and there we will discuss more about the entropy. So please revise these concepts. Try to solve some numericals on your own, so that the concept becomes more and more clear. And if anybody is having any doubt in any of the discussion I have made, you can join me on the Telegram. And you can ask me your doubts. And do join me on 20th at the same time, 8 p.m. so that your concept will be more clear by practicing more and more numerical. Thank you, Sandeep. Thank you very much. So again, I wish you happy Holi in advance. Enjoy the festival of colors with your loved ones, and do not forget to study. That is the prior objective of each and every student. Hi Parvinder, you are also there? Oh my God. Good to see you after a long time. That is all from my side, guys. Thank you. Enjoy. Take care. Have a good night. Stay safe. Stay motivated. And गेट का रिजल्ट आ गया? अच्छा, फाइनल आंसर की आई. Wow, Parvinder, definitely your hard work really pays off. Thank you guys. That is all from my side. Jai Hind. Take care. Sabba khair. Thank you.